All right, so we're going to get going here. Today we're going to be talking, kind of diving into details on a number of things that we introduced in the state of IAC. So if you've been to some of the other sessions, we're going to kind of get into detail, and we're going to do that in kind of a hands-on way. So we're going to be doing lots of demos. We'll start out by introducing ourselves. We're all on the Azure deployments team. We focus on Terraform, so we work very closely with HashiCorp. Our team owns essentially anything to do with Terraform at Microsoft, at Azure. So we own implementing providers, so the AzureRM provider, AzAPI provider, a bunch of tools that help help you use Terraform on Azure. So that's me.
Hey everyone, I think some of you might have been at the Terraform 101, but if not, my name is Steven. I work alongside these two with all the Terraform stuff, and I also manage the community, which we will have a QR code towards the end of the session about. It's a great place to sort of join in and learn about some of the different things that are coming up in this space, as well as work with other practitioners who are really, really brilliant. So.
Thank you, Steven. Hi everyone. Maybe I have met some of you in the morning session, and if not, I'm Jingwei Wang, and I'm a technical program manager at Microsoft as well. And I work closely with Mark and Steven and Alex on everything related to Terraform. So we will try to improve our better user experience and make some product iterations and everything related to that. So appreciate your participation for today. Hope you enjoy that. Thank you.
Awesome. So what we're going to get through today, we're going to go over Terraform export. So I showed it in the state of IAC. We'll go in a little bit deeper today and really get you understanding what you can do with that and the power of it. We'll talk about Azure Verified Modules. How many of you were in the Azure Verified Modules just previously? Okay. We're not going to repeat everything that they said there. They went into it in way more detail, but we'll just show you kind of a hands-on as part of a process how you might use that. Then we'll talk about Azure and GitHub Copilot. So like I hinted at and didn't get to demo in the state of IAC, we're doing some implementation so you can use the Azure Copilot to actually ask Terraform questions and get Terraform code back. But we're doing that in VS Code as well, so you can go into VS Code and do it right there. And so we'll show that, and then we'll talk about the AzAPI provider. We introduced it both in the 101 as well as in the state of IAC, but we'll really dive into that and show you what the benefits are of using that and how you can use it. And then we'll talk about Azure Migrate, so another one of those tools to help you if you're already using AzureRM and you want to move to AzAPI. We give some tools to do that as well. And then we'll open it up for questions. And the way that we're going to go about this, we're not going to slide point you to death. What we're going to try to do is essentially go through a somewhat real-world scenario where we have existing infrastructure in that shared resource group, and we want to create a new resource group that utilizes some of that information from that shared resource group, and then a whole bunch of new resources as well. So we'll go through and actually build the code for that blue resource group using some of these tools and shortcuts and stuff like that. So, sound good? Yes, okay. Cool. I'll hand it over to Steven here.
Awesome. Thanks, Mark. Out of show of hands, how many of you use Terraform regularly right now? Okay, good number of the group. We will try to go easy on you all for the rest of the group. I think this Azure Portal export is a great place to get started. Quick question is, what is this a picture of? Anyone have ideas? If your answer was a typical DevOps engineer, you would be correct. The main thing that happens for most Azure Terraform DevOps engineers is that there is essentially ways that things are defined in Azure and the way that things are defined in Terraform. And those don't always line up one-to-one. There is a bit of a translation layer that has always existed there and continues to exist. How do I get this Azure infrastructure into Terraform? Maybe you click opt your way into getting something and you like the way it looks and it's this shiny object you like to look at. But you have no clue how to represent that in Terraform. The other thing that you might do is you might have a new feature that comes out and you're like, hey, I really want to try utilizing that. I also have no clue how that works in Terraform because we don't even have documentation out for it, or it's still in preview. There's a variety of reasons that that could be the case. Now, what ends up happening for a lot of you as customers is that Azure and Terraform, they really just need to work together, and there's not a simple way to do that in the past. But what we've heard for years is that people have been looking for that. So we created initially a binary tool, and we called it Azure Export for Terraform. And the two things that it really tried to solve is it would try to move existing Azure resources into Terraform, including state and all of that, as well as just sort of helping you establish a reference for your ClickOps deployments. If you had your blessing on that portal deployment, you wanted to be able to see it in the form of a Terraform representation, we created a binary. If you're curious, definitely check out the binary at that link. But today we're actually demoing a new functionality that's just recently come out. We're just hitting public preview for this, which is the experience within the portal. So I will see if the demo gods will elude me, and let's see how this looks. So, okay, I will escape out. Successful escape. And now we'll take a look, and for today's example, we'll just go ahead and use the key vault. So in this little shared group, this key vault is set up exactly how I like it. It has received my blessing. So now I want to go ahead and use it in Terraform. Now, as we're running this, we should run into an error, and that error exists because we're not registered for the provider. So if I go ahead and click here, there's actually a link that I can go to that explains how to register it. Your natural question might be, why is this not registered by default? To which I will say, for reasons. But in terms of the way that we're going to do it, we listed here the terminal and the portal, and we're going to update this soon. But today we're actually going to try just doing it through the AzureRM resource provider registration resource itself. So if some of you are familiar with this, you can actually just go ahead and apply this, and it will run that registration operation for you. I have never tried to Terraform apply with one hand, but here we go. I've actually already done my init previously, and just in the interest of time, for those of you who aren't aware, plan runs before apply anyway, so I can run this plan, see what it ends up generating, and then apply it. And then once I vet that and make sure it all looks good to me, I'll just hit yes, and then it will actually go and apply the resources. Any questions on any of this, by the way, while we're running through this? Definitely want to make sure you get some questions in as you want. So, okay, silence is a no. So we're going to let that apply run. It's just going to create this one resource. It seems pretty straightforward. And then it will go ahead and take its sweet time to do that. Yep, so while this is going ahead and running, we have a few different things here that are obviously currently empty, but we are going to fill in as we go. So there's going to be a Cosmos database, there's going to be the main.tf where we're going to stand up the resource group. We also have this little Excala draw, which has that diagram. I don't know if I'm going to be able to show this in a nice, neat way. Okay, that is very hard to read for you all. Where you can kind of see that right now what we're going to do is do this key vault and move it over to the new resource group. So we're kind of simulating this scenario where you're like, okay, I like how it worked in the old one, and now I'm going to try to reuse this in the new one. And then later on, we'll actually show the same thing with a service bus with AzAPI. But there's some other stuff here, including the AVM module, which will come up next. But our apply is complete. So I've stalled for long enough, and we can go ahead and look at what actually ends up coming up here. So I think I will just need to go out, refresh, and then go back in. And let's see if that works. Everyone hold their breath. This might run for a little bit, but oh, here we are. So this code is going to be a little bit hard to thoroughly read. By the way, is this on as well? Okay, I'm going to free up my hands here so that I stop trying to do things with one hand. I will copy this code since it is extremely difficult to read from there. And I will go ahead and paste it into my main.tf, which is right here. And you can see that they've kind of tried to ease the whole setup for me. They actually gave me the Terraform block, which for those of you who aren't familiar, you need to define this to specify what required parameters you are using. The binary will, or in this case rather, the API is going to actually pin to a specific version. And that's just to make sure that we maintain this tool and it doesn't have any breakings, because those releases are weekly for the AzureRM provider. And then you can see all the different properties that are configured and exposed through AzureRM. Once I go ahead and look at that, I would go through a process of sort of refactoring this, making it look more like the code that would match all my best practices and standards. And then I would go ahead and do a Terraform apply on this to create within my new resource group. Similarly, I would uncomment this and apply it to create the resource group that this is all going to be standing in. So I know that's a little hand wavy because I'm not actually going to do all this now, but that's on a high level how this all works. All right. So what's kind of coming up next? There is a few things. Number one, we definitely want to make sure that you can have support for the choice of resources. Well, right now what we support is essentially clicking on a single resource and exporting it, or exporting the entire resource group. Sometimes you might not want to do just one or the other. You might want to do a subset of the resource group. So we're definitely working on that. The second thing is, for those of you who are familiar with import blocks are actually a lot cleaner than trying to paste in the pre-existing code, because what they will do is when you run them, they'll actually generate the code and do it in a way that essentially doesn't corrupt any state or throw any errors within Terraform. And then the last thing there is that we are doing some early investigations into how we can sort of clean up and massage that code as it's being output, so that you can end up with something that you don't have to then go and tidy up, but that you yourself can sort of utilize as you need in a much more high quality code standards. Any questions on any of this? Yeah, if it's supported in AzureRM or AzAPI in either of those providers, it will work in either of those providers. If it's not supported, it's going to just say, hey, we needed to skip. Here are the resource types we skipped over. You can actually click and see what it skipped over, especially for resource groups. That's helpful because, yeah, if that answers the question. Mm-hmm.
Steven, when you export with the provider AzureRM, it has to be then deployed with AzureRM as well?
You could obviously change the code. That's actually a good question. The code itself is just AzureRM. It's HashiCorp configuration. It's HCL code. It's not actually because the code exists that the actual infrastructure has been applied in the sense of how Terraform thinks of it, because no state file exists with that code. So what'll then happen is you will actually need to not just have that code, but you'll need to run an import statement or an import block, for those of you who are familiar. And that will then essentially give Terraform the rights to take that resource under state management and start managing its full life cycle. The import blocks that I mentioned on this slide, they don't actually generate the full configuration. Rather, they are a Terraform native behavior where you can essentially map a resource ID and a resource within a Terraform provider, and it will generate the code from there when you do a Terraform plan. So that is actually why we want to make that import block support there because that's what you're probably going to do if you actually want to manage the existing stuff in your Terraform environment. The code that is currently there has a flag set called full properties, where it essentially will expose all the configurable properties, because right now that scenario is essentially trying to cover the, hey, what the heck does this actually look like in Terraform, rather than necessarily trying to use the existing one and try to manage and juggle the state. All right, any other questions? If not, I will hand it off to Azure Verified Modules, which I think, Mark, you're covering.
Yep. All right. For those of you that were not in the AVM session, I'll give a quick overview of what Azure Verified Modules are. If any of you have used Terraform in the past, you're aware of the registry, the Terraform registry. You've probably gone there and seen or looked for, if you're using Azure, looked for Azure modules. You probably found them and said, sweet, I'm going to use these. And then you discover, wait a minute, this thing hasn't been touched for 3, 4, 5 months or more. And there's really nobody maintaining or looking after this thing. And in addition to that, you've noticed that why are there 4 different virtual machine modules all from Microsoft? And the whole purpose of, or one of the whole purposes of AVM is to normalize the modules. So there's a set of modules that are supported and maintained by Microsoft. We have a repo where we answer issues on a regular basis. We design the modules in a consistent way, and we do it in a way that is aligned with the WAF, so the Windows, or the best practices, essentially the Azure best practices. And especially around resilience and security. So you get modules that you can trust, you know that they will be kept up to date, and they will work. Let me jump right into a demo of how to implement essentially AKS using a verified module in our scenario here. Assuming that switched over, I am anal retentive, so I am not going to leave this code here. So we have the code that Stephen imported here for the key vault. So we have this resource group that we are going to create. We're going to have a key vault in there, and now I want to put AKS in there as well. And I'm also going to change this because that'll drive me crazy. And I will touch on this, but we've defined some variables here that we'll be using in our configuration. So just I think 3 or 4 different variables. So just a resource group name, a container resource name, a set of tags, and address spaces for Kubernetes to use. So those are just done ahead of time. So what I did here was essentially just said I want to use a variable. I don't want to put a hard-coded string in here. I want to use a variable, and I want to use the variable named RG name, or the resource group name. So when Terraform runs, it's going to replace that with the variable. And you can use this from a module perspective, so you can have those variables in this variable file. I have defaults for the values themselves. That just simplifies the process where if you have those names, you can run the configuration. You don't have to pass anything in. If you want to make changes to that, you can pass information into Terraform when you run it, and essentially replace any of those values that you want. So you could reuse this to deploy to different resource groups and what have you. So it gives you a practice for doing that. So I'm going to jump into the app here, but first I'm going to go over to the AVM website here. So this is just aka.ms/AVM and gives you an overview of Azure Verified Modules. There are 2 types of modules that we're going to talk about today. There's a resource module and a pattern module. The resource module is essentially the lowest level block that you would want that's functional from a module perspective for any given thing. So in this particular case, like if we want AKS, I can search for that. And there's a resource for the container service managed service or managed cluster. So in there, this is essentially just configuring. It has no opinions. It has no default values. It is an implementation of the managed cluster using a number of resources. You can see that it's not just a single resource in that module, because then why have a module? It actually has all of the dependent modules in there, and there's some logic in there where if you want to use Azure Monitor and those types of things, it'll configure that for you. But one of the things I wanted to point out here with these base level modules is they support all the values, and like I said, there are no real default values. So if you want to deploy Kubernetes, you'll be looking at a few different properties that you need to figure out what in the heck all of those things do and what you want to set them to. If any of you have ever been to the portal, you know that if you go to the portal and try to deploy Kubernetes, you're given options. Like if I want to deploy a dev cluster or a economy cluster or a enterprise cluster, you can select those, and it creates a bunch of defaults that are good for that particular scenario. In AVM, there are pattern modules. And you can see here there are pattern modules that kind of align with that. So it sets the defaults for those different scenarios. So you'll have the right SKU size for the nodes. You'll have the right number of nodes, the right connection to AD, and all of those things already configured in here for you. So I'm going to do the production configuration here. And you can see here that it still has a whole ton of different resources in there that it's going to configure. But when you look at the required properties, there are far fewer required properties that you have to pass in and configure. So I'm going to go up and grab one of these examples, a default example. So they have really good examples in here based on your scenario that have some values filled in for you. So in this particular case, to deploy an enterprise managed cluster for Kubernetes, you can see that this is the configuration that you need. How many of you actually have tried to stand up Kubernetes using any declarative language whatsoever? How many properties have you had to pass into that? Yeah, it's literally like 50 or 60 properties you have to fill in for it. So having kind of this opinionated configuration will save a ton of time, especially being able to choose, okay, I'm just doing a dev environment. I don't want these big giant SKUs or anything like that. You pick the dev verified module, and it streamlines that for you. So I'm just going to go ahead. So this uses private endpoints and a number of other things. So I'm going to copy this code here. And the virtual network, and paste it into my configuration. Let's go back here, paste that in, and you will see a bunch of red squiggly because it's not valid code yet. But I'll start out with the resource group here. So update this code to use my variable. So this is going to create private links or private DNS zones for both the AKS cluster and ACR. And then I'm using another module to actually create a virtual network as part of the process there, or just to streamline this. And for these, I'm going to use a variable as well, the address space. And I'm going to use, I forgot what I called that. For some reason on here, the suggestions are not working for me, but these are the values that I want to put in for the different ranges. So I'm just going to put those in here real quickly. AKS VNet. Now it's working. So that gets the virtual network set up, and this is a virtual network that AKS will be in. And then if I come here, what this is yelling about is the reference in the documentation itself. It is using a test module, so it's a module that's actually in a subdirectory. In my case, I want to actually specify the module that's out on the repo. So if I just grab the source string here, I don't need to copy it, download it or anything. I can just reference that module that's out there and use it, give it the version I want to use there, and then come in and replace some of these values. I'm not going to go through all of these for the sake of time, but you can see that you can very quickly get up to speed on deploying Kubernetes here. So with a handful, not handful, maybe 15, 20 lines of code with 2 modules, you can deploy an enterprise class Kubernetes cluster, which is pretty good. And it's aligned with best practices. So, all right, from there, we're going to jump back to Copilot, and I will hand it over to Jingwei.
Okay, thank you, Mark. I will just use this phone. So before I get started to introduce the Azure Copilot for Terraform, I'm very curious about how many of you have actually used this Copilot for your Terraform workflow in the Azure portal. Can you raise your hand? No? Oh, so none of you have used. So it'll be a very great opportunity for me to briefly introduce the principles, logic, and show you some demos with regard to that. So let's say that I will continue the story that Steven and Mark has just shown. Is that let's imagine you are a software engineer and you want to deploy several microservices within the Azure container environment, probably using the AKS. And one of the most important segments for you is to deploy the host the MongoDB. So probably you are new to this Azure service and you want to seek some assistance from some channels. That is when the Azure Copilot could be of great help. So let's jump to the portal. Okay. Oh, sounds good. Yeah, so the channel is here. When you log into the portal, the Copilot button is right over there. You just click on it, and it will raise a conversation window. And you can put this question here: what is the best and the most scalable option for hosting the MongoDB in Azure? So Copilot will trying to generate the answers. It might take like 16 or so minutes to finish this. Oh, seconds. Sorry. That's horrible. It's 16 minutes.
Does it know the context that it's going to give it in Terraform?
Yeah, because we have. The first question is we don't ask specifically for Terraform, and if we like have the keyword with regards to Terraform, it will direct you to the Terraform handler within the portal.
Maybe that was going to be 16 minutes. So what this is doing right now is the Copilot has what we call handlers or skills behind the scenes. And the default handler that it uses is the Microsoft Learn handler. So it's going to go to Microsoft documentation and try to get the answer for you on kind of options that you have for actually deploying MongoDB in Azure. And then the next step will be specific to Terraform, and then it will come to our handler and actually try to get that answer from there.
I don't know why this is happening, but it seems to take longer than I expect. It never happens. So I have a backup here. I have made a video before. Yeah, we can refer to this. Oh, sorry. Let me just. Okay. So I will put the same question here, asking the same question, and the Copilot will try to generate the answers. Basically, it will answer that the Cosmos DB is the best and the scalable option for hosting the MongoDB here. And then we can ask it a follow-up question like, how can we configure this Cosmos DB using Terraform? And the Copilot will try to generate us with the answers with the Terraform configuration files. So this is how it works to help with your current Terraform workflow. For this generation process, it generally takes like 16 seconds or so. And yeah, so after that, it will generate the HCL configuration file in this code block, and you can simply open it up in the full screen here, and you can check everything here, and then we can see there's a Cosmos DB account has been generated in the Cosmos DB database. And when we copy and paste it into our VS Code extension, we will find that those resources are all clean and clear and without the red lines, which means that we do not have any hallucination problems currently, which indicate our high quality to some extent. Okay, so after going through all those, I want to highlight that our efforts that has been always continually put into the quality improvement. With regards to the quality evaluation, currently we have a quality evaluation score that has been showed here. It is actually being calculated based on the testing problems, each question's correctiveness and relevance, and we will sum them up and have a weighted average to calculate the final evaluation score. So we can see that from the very first beginning version of our GPT playground to our current Terraform Incorporated GPT model, the score has been increased from 61 to 86, which is a very tremendous growth. I will introduce a bit about what aspects have actually contributed to this quality improvement, some of the highlights here. So first, we have been switching to the latest GPT-4o mini model. This model is more advanced because it will generate fewer hallucination problem, which means that the generated resources are actually real exist. They are not from imagination, and this will improve our generated contents quality. And for the second is that we have tried to add the Lomo index customer query engine. It means that we will try to accurately retrieve the most relevant information from our inside information knowledge database, and we will try to generate the most relevant answers and the code generations for you. So this also greatly contributes to our quality improvement to some extent. And the third thing is that we have been trying to add the Terraform validation logic to the whole process. For instance, if we identify a validation error during the process, we will try to reach out to the large language model to make modification and do the Terraform validation logic again until the answers before the answers actually reach the customers end customers, so that we will make sure all the answers have generally passed the TF validation logic. And for the fourth one is that we have tried to add the rewrite logic. This means before your question, you ask the Copilot a question, before your question actually reach the GPT model, we will try to rewrite your question at the very first beginning so that to enhance the relevance and the quality of the RAG model here. So that is all the quality-related improvements that we have been made in the last few versions of our GPT model. And so on the horizon, we will continue focus on those areas. So first is still our quality, because we believe that quality is still the very important section, the most important section for the AI-generated content. And we will also try to focus more on the speed, because many customers have responded that they may get very impatient if the response time is so long. So we will try to seek a balance between the response time and the quality improvement here. And for the third aspect is that we want to enable the Copilot to support more complicated, more advanced scenarios. For instance, like the application landing zone, and to support the full architecture instead of just focusing on the segment of your architecture. And we want to also like support the migration process if you want to migrate from other cloud platforms to Azure, or you want like the Terraform to take over your existing infrastructure. All those more complicated scenarios, we want our Copilot to be of help. And these areas has all been on our radar now. And we have also planned on some new features, and they are either like on the shipment way or about to ship or under our planning. The first is that we want to introduce the context awareness in Azure. So currently, all the generated answers are solely based on our conversation history. It is a single channel. And in the future, we want to incorporate awareness of the open files and your existing infrastructure, your existing Azure resources, so that our Copilot can try to provide more customized and tailored answers according to your user's profile. And for the second, I will do a demo later on and just give you a heads up that it's called direct editing in the portal. It will actually allow the users to direct edit and interact with the generated code. So you don't need to leave this portal and direct to other platforms. You can do everything within the portal, like the code editing. We will try to provide you with a very similar experience that you have in the VS Code extension, like the syntax highlighting and auto completion, etc. So this is a very convenient function, and I will show you more about the user experience later on. And for the last one is that currently our Copilots only serve the Azure RM provider, resource manager provider, and we are planning to support in the future the Azure verified modules and AzAPI providers as well, so that you can have more much better user experience. You can handle everything with the assistance of the Copilot here. So I will then get started to show you the user experience of the direct editing within the portal. So this is the current user experience.
We have a question.
Oh, yeah.
Are there any inherent advantages to use Copilot in Azure versus using GitHub Copilot, where it kind of already has some of that context awareness that you have your Terraform folder open? Is there any advantages to using Azure Copilot over GitHub Copilot for use case like that?
Actually, the backend of both are the same. We are using.
No, finish.
Yeah, the backend are the same, but maybe they have different target groups. Like for the Azure portal, they might be have lower entry bars, so might be more suitable for some beginner users. They can have a much easier user experience. And for the GitHub or VS Code extension Copilot, they can be more aligned with your coding experience if you have more expertise in this area. So just for different scenarios and different user groups.
So one of the other things, as Jingwei pointed out there, we do a lot of work behind the scenes to make sure that the code that comes out is valid code. So the kind of generic, I'm going to ask a question and throw it at the LLM, there's no real validation, and you're basically trying to get, or not trying to get, what it's using is all examples everywhere in the world, essentially. So it might be good quality, might be bad quality. It's definitely a mix of quality, where when we use our backend, our handler, we have a set of known good examples that we're essentially passing into it. If you ask about Cosmos DB, we're getting some known good examples, passing it into that, so you get a much higher quality response. In addition to that, we do some iteration as well, as we were talking about there. So Terraform has a command called validate, which you can basically say, I want to validate this code, and it checks the syntax and a bunch of other things. We actually do that on the code before we return it. And if it's not valid, we pass the error back into the large language model and say, fix this. And we do that a couple of times. So you get a much higher quality response with our handler.
Oh, thank you, Mark. Thank you for the question. Oh yeah, I just asked the question how to configure the Cosmos DB in Azure using Terraform, and it's much quicker than just now. And so but the full screen editing experience is currently not available in our production environment. So I have actually made a recording beforehand. So after it get released, the Terraform, our current experience is that when you ask it a Terraform related question, it will generate you with the answer with this code block, like this HCL code block. The visualization is not that good because it's all crammed into the corner and you cannot get sufficient experience from this visualization. So to help improve that experience, we have made some improvements here. Let me... or just yeah. So you will have a button called edit, applying editor. This name will be changed maybe later on, and there will be a full screen editor that being opened on your left hand side. You can see that the content in this full screen editor is exactly the same as you will see in your Copilot sidebar code block, and there's some syntax highlighting here, just similar to what you have in your VS Code extension, and you can download it to a local environment or copy the content, whole content, or several lines of your code here. So that is what we have been doing recently, and you will probably get to see this experience in handover over weeks. And besides that, we have also been working on the iteration 2 of this full screen experience. One highlight is that we will currently all the generated Terraform files are all condensed into the one single file. So to help improve this experience, we will try to excuse me. Categorize them into different categories, like the main.tf, provider.tf, output.tf, and the variable.tf, so that it will be more aligned with your current user experience here, and you can click on them, and you will be navigate to the corresponding content on your right-hand side. So this is the first iteration we want to make. And the second highlight here is that we will be trying to introduce a function called draft with Copilot. So after the configuration file is generated in the editor, you can trigger out this dialog windows. It's called draft with Copilot. Oh, thank you, Mark. Draft with Copilot, and you can ask follow-up questions here. For instance, just help me fix the common issues in this configuration file, and all the changes will be marked with highlights here. For instance, those to be deleted will be marked as red, those to be added will be marked as green here, and you can also put some simple commands to make quick operation. For instance, like the dash fix or dash close down, etc., to ease your user experience. So these are all in our planning right now, and we expect to maybe release it in haven't had a very exact time of releasing, but it's right on our radar to do it. Okay. Yeah, that's all for this section. Does anyone have any other questions? If no, I will hand over to Mark again.
All right. So you asked about, so a lot of the feedback that we have got from customers is that stuff you've done in the portal with Copilot is cool, but I don't spend my time in the portal. I spend my time in VS Code. So we're in the process of working with the GitHub Copilot team to integrate with VS Code. So they have the concept of participants. So if you're in VS Code and you do an @ something, it's a participant that you're talking to. There's an @ Azure participant, and we're integrating with the @ Azure participant. So it's going to use our handler in the backend. So you still get all of that work that we're doing, but in Visual Studio Code. So I'll give you a quick demo of that here. If I go to VS Code, if I open a chat window here, so I'll open chat, and I'm getting ahead of myself, but if I do an @ Azure, so you have a bunch of participants that you can talk to. @ Azure is for essentially anything in Azure. So you can get the same learning responses, and if you mention Terraform, you'll get our handler and responses from there. So if I want to, what do I want to do? Show me. So I'll ask for the API management to get a configuration for API management. Oops, I apparently am using the Sonnet model. This is irrelevant in this thing because it's going to come to our backend and use whatever model we have. So, but it's going and thinking about that, and you can see once it gets through the working here, it's going to say generating configuration or Terraform configuration. And that's, it's past that already. But when you see that, you know that it's talking to our handler and getting that response back from that. So what I will show here is, again, like Steven showed early on, when you generate this using export or from the Copilot, we try to give you a full working example. So we're not going to give you just a chunk of the code. So you can see the provider block because it's giving you a response for AzureRM. So we give you the provider block so you could take this whole thing and dump it into your code and know that it works. So I will just go down below here and tell it to dump it into my browser. And one of the things I will point out is we do have syntax highlighting and everything here. So you'll notice that there's no hallucinations here. All of the properties are valid, and all of the syntax for the resources and everything are valid as well. You'll see that there are no variables or anything here. We are working on having more robust responses as well, so it'll have variables and all of that in here. But just wanted to really highlight that we're doing work in the portal, and we're making sure that it is where you're using the code as well. I'll also point out, I don't have a demo for it, but you have the agent mode down here. We are beginning to work with the team that owns that at Microsoft as well, so that it's not going to use our handler in the back end, but we're working with them to make sure that they're doing some of the same processes, so you get that high quality response from that as well. So you really have a full suite of different options for actually using Copilot and getting high quality responses. Because I don't know, how many of you have tried to get Terraform, PowerShell, Bicep responses from handlers? How often is it correct?
It's correct, but often incorrect.
Yeah, that's kind of our experience as well. Is it's cool because it gives you answers, but then it will take you a little while to get going from there. But our goal with our handler and working on this stuff is that when we give you a response, it should be accurate, and you should just be able to run it from there. So, any questions on any of that? Does it sound useful? Awesome. All right, I'm going to hand it back over to Steven, who will take us to the finish line here.
All right. Yep. It's going to be just me up here for the rest of this. So if you don't like seeing my face, you can leave. But if you're okay with that, we're just going to run through a few more things, if that's all right. First, I want to talk about AzAPI. Some of you who might be familiar with the history of Terraform might not be aware of the provider, or maybe have heard of it. But for the longest time, AzureRM was the provider, the only provider that you could essentially manage anything in Azure with Terraform. But one of the number one pieces of feedback that we always heard when we talked to customers like yourselves was, hey, something exists in Azure and it does not exist in Terraform. And we would like to use the thing that exists in Azure. So we always try to maintain a GA requirement, general availability. Whenever services went GA or generally available, we would say, okay, we will make sure we'll support that. For reasons, things don't always work out that way. So there are certain things that we ended up having to support a little bit later, and obviously that was not a great experience for all of you. So we teamed up with the folks at Bicep, who happen to also be part of our team, and worked together to create this provider, which is now on 2.0. So if you played with the V0 or V1 iterations of this, you were working in JSON. Thankfully, that is gone now. That is never coming back, I promise. And in V2, we have several features that we want to call out. Preflight is one that I will immediately highlight. If some of you aren't familiar with how Preflight works, it essentially is a backend API that will catch errors of two types during the Terraform plan phase. This is a provider-enabled feature flag. The first thing that it can do is it can say, hey, if your SKU is invalid or if some sort of basic resource provider sanity check fails, it will immediately tell you that that's going to fail without you having to run an actual apply. The second thing it can do is it supports Azure policy. So if you have your policies set up and you're not actually allowed to create a storage account of that tier, it's going to tell you before you actually try to apply that thing. The big thing that we've seen is sometimes these configuration files and environments get really big, and you do not want to be sitting for that whole Terraform configuration to apply, and on VM number 58, it decides to just throw an error during that apply. So this really helps reduce that, really helps try to curb the problems that are going on there. Second thing is the VS Code extension. We've put a lot of work into this. I will demo some of this in a second, but we have a wonderful VS Code extension that has taken a lot of inspiration from the Bicep extension. We have a paste as AzAPI code sort of example, as well as code samples that are auto-generated or built on the language servers within the AzAPI provider itself. The other thing that is actually supported there, and that I will talk a little bit more about later, is migration. So you can actually migrate code from AzureRM to AzAPI within the extension. There are some caveats to that, namely that it needs to exist in state. But if you have it in state, if you have the resource deployed, you can actually go ahead and run that. And with all of these different changes that we made over the years, we wanted to sort of come out with a new provider messaging. At first, we kind of called this a gap filler. We said, use it until AzureRM supports things and then switch on over. But we've kind of retracted that statement now. Nowadays, the statement that we will give is use AzAPI if you want to use the latest features and work in any sort of more environments in which you need more control, such as module development, being that platform team that is spinning up these modules that other teams will consume. But if you're looking for simplicity, if you're looking for stability, if things aren't broken and you deployed it in AzureRM 5 years ago, you can keep using AzureRM. And that is sort of the stance that we have taken. There is a QR code to the blog post. That is also a blog post that HashiCorp released another version of alongside with us, just to really show that we're on the same page here. Yes, one of them is considered an official provider by HashiCorp, and the other is considered a partner provider, but all of that is really just semantics at the end of the day when it comes to how all of you can be using and utilizing Terraform on Azure. And if you're not familiar, I do want to highlight a few things that are uniquely beneficial about AzAPI. The day zero support, sorry, I'm skipping ahead. First, the constraints around subscription ID. If you're on AzureRM 4.0 or if you're on any version of 4.0, then you need to specify your subscription ID. If you're ever trying to handle situations where you're dealing with multiple subscriptions or heck, multiple tenants, you're going to have a lot of problems there. And the nice thing about AzAPI is that it can actually free you from that. The other thing is AzureRM, because of its unique design, is abstracting abstracting the resource versions away from you. So when you pin to a specific AzureRM version, you're not actually exposed to or even necessarily aware of what API versions you're using under the hood. That means that you're sort of at the mercy of if one part topples over and you really need functionality in the next version, you might not be able to upgrade to that next version because something else in your infrastructure is dependent on the previous version. So that sort of constraint has bitten people in the past, especially when it comes to bugs and needing new features. The second thing that I'll talk about is that there's day zero access to all Azure resources and features. This is in particular control plane. Anything that you want to do in the management planes and the control planes is supported without any effort from our side. If you even happen to know what the schema sort of is represented as, you can make the call almost to anything. We've seen some community members do some really interesting things with AzAPI, like generating a region randomly within a set of lists to help with your spinning up your test environments. So it is faster because there's a thinner wrapper around the APIs. It'll just move faster. It actually also has consistency enforcement and other race condition gotchas that it can handle with some of the different more granular controls. I will breeze over that, but if any of you are module developers and care about stopping or catching errors with long-running operations on creates, if you care about other race conditions, just come and talk to me and I'll kind of demo that or explain it to you. And then lastly, I just talked about the predefined policy stuff. So in terms of what I'm going to demo, I have two things that I want to show off. First is, and they're both related to the VS Code extension. So hopefully, if nothing else, this will convince you that if you're going to use AzAPI, you need to use the VS Code extension. So first thing I'm going to do is I'm just going to come right back in here. I'm going to close this chat, which thankfully does not blow anything up. And then I'm just going to go ahead and define a resource in AzAPI. Oops, we are having a fun time today.
Escape out of the presentation.
Oh, sorry. Second time I did that. So let me double check. If I scroll down here, there is the Terraform AzAPI provider. Want to make sure that that is working. And as you can see, 5 stars so far. So we're doing pretty well. In this case, I said that I was going to do a Redis resource. So I can go ahead and immediately GitHub Copilot is trying to help me. But for the sake of today's example, I'm just going to go ahead and start specifying the type. As soon as I specify the type, all these different options pop up in front of me. I want the Redis, so I'll do that. And then I'll pick the latest stable version. I'll also set the parent ID to be the AzureRM resource group. I believe it should be this one. It will be okay if it's not. And then if I, from here, go and do a command space, command space is not it, control space, I will get the ability to see this code sample. So these code samples are here to really help you get started. And if you ever actually have looked at the AzAPI reference docs, those are oftentimes schemas and they're not necessarily indicative of what a working example will look like. These code samples are much more close to the reality of what a getting started or a quick start would look like in terms of a reference. So I can go ahead and hit enter on that. Now I have all these values in here. I can go ahead and start playing with that and configuring and spinning it up the way I want it to. I'm going to not do that for the sake of time, but any questions about this first section before I keep moving along? All right. The second thing I want to show is we're going to come back over to our resource group, which now I want to actually go ahead and say, hey, for this service bus, I actually want to go ahead and manage that in the AzAPI provider. So there is, if you ever go in the portal, this JSON view that you can click. And if you open it, it will pop up with this wonderful JSON, which we all love and we want to author in forever. But if you go ahead and use the extension, when you do a paste, and it completely hides everything. Oh, that is not what I wanted. see here. Control C. No. Control C. Command C. Command V. There we go. It will automatically create this namespace AzAPI resource for me. So all I did was take that resource JSON. I knew nothing about how to configure it in AzAPI. I didn't need to. It mapped this to for me. And the nice thing is because this is based off of the JSON, we have high guarantees that it's going to be actually a correct and representative configuration. Now, do I want my parent ID to also show off my subscription ID? Probably not. But I can work my way from there and start deploying it. There is this nice little note here that says it's generated HCL content, and it gives you two ways to import the resource. You can import it within the console, or you can comment this little code, and when you run this in Terraform plan and apply, it will bring it in a state and not scream at you about the fact that it already exists outside. So this is just another way that we're trying to reduce those barriers from that ClickOps scenario into your DevOps environments, and we really do think that this can be helpful. Oh, and did I mention, this also supports ARM templates. So if you ever have ARM templates that you want to bring under Terraform or under AzAPI management, this is another tool that you can utilize in that space. Any questions about this?
More about the import statement. It's kind of a bit vague to me. So you have an existing resource which you created via the portal, like manually, and you want to bring it on the Terraform's management. After I run the import statement, and let's say that it's now in the state of Terraform, I would want to modify like a property. I assume that I want to do it via code.
Yes, so
How would that look? I mean, does it ever get like a resource in your file then? Because it's only an import statement, right?
So this import block right here is essentially helping you with, there's a couple things there. So first of all, if you run this import statement here, and how am I doing on time? Maybe we can humor in this and see what happens if I run it live.
Plenty of time.
Okay, so what I will actually do is I'm going to live wing it, and let's just actually see what happens if I create a separate folder here. And I'm just going to name this test, and in test I will create a file, and I'm going to go ahead and take this stuff right here, and let's just see what happens when we spin it up. So Command C, Command V. So when you run it with this, oh, I need to save it. Oh, I need a provider, sorry. No, I want to copy.
So that import statement should be in addition to the configuration. So when you did the import, it pulled in a representation of that resource itself and the import statement. So the import statement will pull it into state, and then you'll use that resource block to actually do the configuration from then on.
So we'll basically update it then every time, or
Yeah. It'll be under Terraform. The import statement essentially says that something is out there in the real world and I didn't create it from a Terraform perspective. So I want to import it to Terraform, and then I can use Terraform to manage it from then on.
Okay, so the import statement always has to be there. It's not like we can remove it after the first run.
You can, I think you can remove it after the first run. Yeah.
It'll be in the state file as that, and it'll match the resource definition.
Yeah.
It's a one-time operation. And the other thing that's interesting about this is if you actually have the ID like this, you could technically run it on newer versions of Terraform, where if I comment all this out or don't have this code, there's actually what they call a plannable import within the import block, where if I just point at the ID, it's going to actually generate the code in the relevant provider for me. And that's especially powerful with the export experience. If you remember, I was referencing the import blocks earlier for export. So what actually we recommend nowadays is instead of generating code that has the resource configuration, we generate just this block. And then you look at the blocks, you vet those, and then you plan it, and then it will generate a config when you run Terraform plan. And if that looks good to you, then you apply it. It's all under Terraform's jurisdiction, and then you remove this, and you have everything in Terraform from there. Yep. So you can see immediately it's recognizing, hey, we're going to do an import here. And it will actually not say add or change or destroy. It'll say one to import because it already recognizes that this is existing. And then if I do an apply, it will run. Might error because I'm winging it live, but it will run and do that. Import. Look at that. So, yep. All right. Any other questions about this?
One kind of question on another topic brought up. For those pre-flight checks and verifications, is that
Yep.
specifically a feature that will be looked at for the AzAPI provider, or is that for both providers sort of in the roadmap?
So pre-flight is a flag that is just configured right under here. So you could just say pre-flight enabled equals true, and then it will go ahead and run from there. For some reason, this is not being friendly with me. Maybe it's up here. But anyways, there's a guide on the registry on how to enable that. For some reason, I'm blanking on it right now. But I think the second part of that question was, is it just looking at AzAPI, or is it also going to try to come to to AzureRM, right? So we definitely have heard that feedback. We're looking into it. The main thing that is there is the plugin SDK, AzureRM, and this is getting a little deep here, but AzureRM is not on the plugin SDK, AzAPI is. That's why actually we were able to do a lot of things with pre-flight integration. So essentially, there's two ways of thinking of it, and we haven't quite nailed down which way we're gonna go. We can essentially create either a binary that consumes pre-flight as a plan output, or it can take in that plan output and spit that out, or we could actually just wait until the plugin SDK movement occurs. And right now, I think, to be honest, we just need to see how much effort that would be. It might be that one ends up filling in the gap while the other one stands up as the long-term solution. But again, we haven't decided. It's a good question, though.
The other thing that comes into play there is because AzAPI is a direct reflection of ARM, it's just simple. It's a one-to-one for us to do the pre-flight, where because there's an abstraction layer in AzureRM, there's some magic we have to do, and we're figuring that part out as well. But it is something that we've heard loud and clear that policy and kind of erroring earlier is way more valuable. So we want to make sure that it is part of AzureRM as well.
Sweet. Any other questions about AzAPI or any of the tooling I just showed? Alrighty, I'm going to go ahead and keep moving along through the deck. So one of the things that we've heard over the years is when new features and services come, the request to the team comes and the manual implementation occurs before we merge into AzureRM. This obviously, for reasons, will trip on itself occasionally, which is why we created AzAPI to automatically generate and essentially support things from day zero. The main question we got once we released AzAPI was, how easy is it to go between the two? And there's a few different reasons why this can be a little tricky, right? First, the fact that you have to deal with versioning. If something is supported in one version, but there's a breaking change behavior in another version, it's not that simple to just bump yourself up to another version. Your state file needs to also not get corrupted. When you're doing all of this, you need to handle the state in a way that is not going to cause things to blow up. And especially, it can be difficult if you're trying to manage a state that doesn't exist locally, which it probably shouldn't be anyway. So if you have a remote state file, if you have a TFC state file, how do you sort of do all of that? And the last thing is, how does your configuration sort of get updated in a way that doesn't disrupt everything? So one of the unique benefits that we've been able to really invest in and put some time into is a binary called Azure Migrate for Terraform. I know the name is just as inspiring as Azure Export for Terraform, but the main benefit of this tool is to essentially create a way in which you can easily move between providers. And this is really the beginning of the story that we want to tell people, which is that you can have flexibility between the two providers. Again, due to the plugin SDK, which if you guys don't know what that is, that's okay, don't worry about it. Essentially for reasons, this is a lot more deterministic right now when it moves from AzureRM to AzAPI. And in the first place, most of you who have infrastructure stood up, it's probably stood up in AzureRM due to the history of the provider. But the big thing that we are trying to push with this is if you stand it up in AzureRM, or if you have these modules that have persisted for forever in AzureRM, you don't actually have to depend upon AzureRM to keep managing things like your AKS, your container apps, things that are constantly churning out new versions that you can barely keep up with, or we can barely keep up with, to be honest. So in those scenarios, this is a great tool to sort of free yourself from the versioning that comes with AzureRM, and you can arrive at, for those designated resources or for those designated projects, we're going to run on AzAPI. We're going to be able to set the versioning ourselves. Yes, that will mean that more complexity is right up in our face, but we actually are able to do so with this binary in a way that preserves the state file, it preserves resource representation, and it actually makes sure that whatever you end up coming out with is going to not break things, is the simplest way to put it. The biggest reason why this has gotten to the point it has, we used to do an iteration, if some of you might have heard of a tool called AzAPI to AzureRM. The big problem there was that we didn't have a good way of managing that state file, but now Terraform has this concept of a moved block, kind of like the import block, but instead it's saying, hey, move it from this provider to that provider. And that is a Terraform native solution that essentially handles state for you. So regardless of it's local, if it's in TFC, if it's in a storage account, that state file will be handled by the innate Terraform core behavior. So really, this is the beginning of, I think, almost a new era in my eyes of being able to actually have flexibility between providers. Where we go from here, honestly, is a bit of a question, but I think that at the very least, for those of you who have felt that pain and continue to feel that pain because of AzureRM staying on those certain versions and being locked to those certain versions, we just want you to know that there is a solution out there. If you are interested in this, it is AZTF Migrate. That is the name of the tool. It's under /Azure/ or it's under the Azure GitHub. So if you look that up, and we will be trying to evangelize this a lot more now that it's had the improvements it's had recently. So we'll be making blog posts. If you're part of the community, or if you're not, join the community. We will also be talking about that more. Any questions on any of this? All right. This is just a brief little summary of the different sessions that have happened this DevOps conference / what's happening tomorrow. If you want to hear more about Bicep, the Bicep folks are going to do a deep dive tomorrow morning. And if you want to learn about CI/CD with infrastructure as code, I'm doing a session tomorrow, and Sydney Smith, who I'm sure many of you know, will also be doing a session in the afternoon regarding Bicep and CI/CD. This is just helpful for all of you in case you wanted to reference recordings down the road. But yeah, just want to make sure you're all aware of the sessions. A couple other things in closing. Number one is please join the Terraform and Azure community. We have, and I've said this twice or once already, but I'm going to keep saying it. We have really, really great practitioners. We have really enthusiastic people. These guys are doing stuff that is just absolutely crazy and bends my mind on what we even think our tooling is capable of. They are ready and willing to answer your questions as you learn about all these different things. And we try to we do host these monthly community calls, and we try to give our community a sneak peek on all the stuff that we are doing and really including them in that way. So highly recommend you join that. And we are in the middle of a season of collecting feedback. So if you use Terraform on Azure and you want to give your feedback, this is another QR code. Sorry, it's a lot of QR codes, but this one is just for feedback in terms of how you're liking your experience. We really do value this feedback from all of you, and we do read through every single comment, believe it or not. So, all right. If there's no more questions, okay, we have hands raised immediately. So there are questions. I will leave that up there if you want to give the feedback, but we'll go ahead and take the questions from here. So you two raise your hands at the exact same time, so I'll let you fight it out.
No worries.
So if I'm managing something like the beta endpoint, like direct REST calls, Do I gotta wait till on the 1.0 before I'll see it in the AzAPI?
No, so Azure RM is going to need to wait until things are generally available. But if it's a AzAPI, if it's an AzAPI, it essentially is auto-generating from the available types within the Azure control plane APIs. So it will automatically have that support from day zero.
It's actually simpler than that. AzAPI it makes direct REST calls to Azure. So the generation that we do is for syntax highlighting and all of that. But if you know a REST call and it hasn't been updated in AzAPI yet from the language server perspective, you can put it in the code and send it and it'll work. So it literally, you can make any call to the control plane using AzAPI.
There's one more thing I forgot to mention there, which is we support what's called a resource action. Now, even though technically these are declarative tools and Terraform's supposed to be declarative, sometimes you want to use a resource action and maybe generate your private key value pair or something like that. That resource action can do some really wonky stuff if you're familiar with the APIs as well. So definitely would make sure if you're curious about some of those imperative workflows and how they would run in Terraform, that's a great place to also take a look.
We're looking at Terraform right now. From Terraform's perspective, we have a greenfield. So what would make me, should I build everything in AzAPI from start? Or would I want to balance stuff between Azure RM? I'm leaning towards doing everything in AzAPI because it sounds more awesome than Azure RM, but
I can start with that, but it really depends on your use case. You can do everything in AzAPI, but if you're a platform team and you're familiar with Azure, or you have domain experts that are familiar with Azure and the concepts and everything, and they can build modules to abstract some of the complexities away, AzAPI all day long, because you're not going to ever be blocked. You're not going to be waiting for us to add features and functionality. But if essentially you're a small organization and people are going to be writing their own stuff and they're not super familiar with everything in Azure, Azure RM has some benefits there because it does that abstraction and makes things a bit easier.
we control it. So
There you go.
that's the answer. Thanks.
And I would highly recommend, if you're a greenfield, going down the the AVM path and the landing zone path, just because it will get you going with best practices. So you don't go down the path of, we're going to roll this out and figure this stuff out, and then 6 months, a year down the line go, oh wait, we didn't do everything right, so we're going to have to figure it out later. So just starting with that is definitely the right way to go.
It's not technically a greenfield because obviously we have it all in ARM right now, and it's all
Okay.
templates, blueprints, so we have to figure out something else. So it's not a greenfield.
So
but
IAC
Terraform.
greenfield.
Yeah, exactly. Thanks.
And AVM is using AzAPI and other covers?
AVM is currently using both. So the subscription vending machine uses AzAPI. A lot of the other resources use Azure RM, but they're actually going to be switching and recommending authors of the AVM modules to go with AzAPI.
So if I'm understanding that question right, and I'm just realizing we were supposed to repeat these for the recording, but alas, the thing is if you're referencing something like an architectural diagram that highlights, here's how to set up like an OpenAI chat model, you don't necessarily know, okay, I can create the resource, I can set the required properties, but what else do I need to configure to actually link up all those little idiosyncrasies that are at the next level? Is that what I'm hearing?
Yeah, I guess I didn't do it, but using the AVM site itself, and here's all the patterns and practices. Typically in the example sections is, here's the well architected framework version of this. Here's the basic requirements, and here's this other one. And there's typically multiple versions of that, but that is only available in the web. It's only in that pattern, as opposed to, hey, I'm just doing this in VS Code, and then here's some other pieces I can get from there. Really, that's really, it's almost like a feature request at this point, But looking at some of what can be possible, I'm like, why isn't that option there? Because it's already over here.
In the sense of having access to those solutions just from the VS Code?
Correct. Yes.
I think that was something that honestly I was thinking about during this week, and I'm like, I don't have a good answer, which is a good thing. That means that we should probably be working on that. So I think that's, I guess, the answer in short, unless you have
Good
anything to add.
feedback. Thank you. Yeah. Any other questions? Does anyone want these awesome Terraform coin things at the folks here? Yes. I'll put them up here. Come grab as many as you want.
All right, sweet. Thank you, everybody. We'll be here if you have any other questions, but appreciate it and your time.